In this tutorial, we're going to walk through the creation of the toolpath in for the Gothic Quatrefoil panel you see on the screen. The vectors used for this example were created in a previous tutorial, which can be found through the related video section on this page. We'll be showing how to use simple toolpaths including profiling, pocketing and V-carving to create this ornate panel. But first we're going to close down this file. And now to start, we're going to open up the existing file created in the previous tutorial. So File, Open. And in this case it's going to be the Gothic Quatrefoil vector drawing.crv. And once opened, you'll see a series of vectors created in the previous tutorial on your workspace. And these represent the outlines of the Quatrefoil panel that we're going to look at toolpathing. Okay, so the first thing that we need to do is just check through our layers. So we'll come up to the layers menu here, left click to drop that down, and we'll see that we've got 4 layers in total. So we've got outline, top and bottom grooves, foils, and V-carve shapes. And if we wanted to, we could just turn the visibility of these off and just go through them individually. So we've got the outline, top and bottom grooves, foils, and finally the V-carve shapes. And the first one that we're going to be dealing with here is the foils layer. So I'm going to switch off the visibility of all the other layers. And we're going to make sure that foils is the active layer by left clicking, which will highlight that in bold text, indicating that it's the active layer. And with that selected, we now want to switch over from the drawing panel to the toolpath panel. So we'll use this button here to switch to toolpath commands. And we can see all our toolpath operations listed here. But the first thing that we're going to need to do is set up our material. So we'll click on set and we'll just check through these. So the material thickness is already set to 1 inch, which is exactly what we need. Our XY datum position at the moment is in the center. So that would be ideal for the vector drawing, but now we're moving on to toolpath and it makes more sense to have that in the lower left hand corner. Our Z0 will be from the material surface, and we just need to check through our rapid and home heights just to make sure that they're safe and appropriate for the machine. So that's all okay, so we can click OK to accept that. And at this point now we can start to think about creating our first toolpath, which in this case would be a set of pockets between the inner and outer edge of each of these 3 quatrefoils. So we can just go through and shift and pick all of those items. So I'm just using the left mouse key with the shift button held down to do that. And now we've picked those 6 vectors, we can come across to toolpath operations and we're going to need the pocket toolpath. So we'll enter into the form. And the first thing that we need to think about is our cutting depth. So we know that we're starting from the material surface, so we can leave the start depth at 0. Our cutting depth is going to be 1/8 of an inch, so 0.125. And now we need to think about the tool that we're going to use. So we can remove the 1/8 inch end mill that's pre-selected for now. And we'll click select to go into the tool database. And in this case, I'm going to be using the 1/4 inch end mill. So I'll select that. We can check over the cutting parameters and feeds and speeds. And then click select and that'll be added to the list. And between the offset and raster strategies, the offset is going to make more sense here due to the unusual shape that we're cutting here. So with that, we can come down and just name this cut out circles, and we can click calculate, and you'll see that that automatically flips into the preview and we can see these toolpaths displayed on the screen. And to simulate that now from the preview toolpaths menu, we can come over and use this run button with the cut out circle selected. And then we can have a look at this closer by tilting the material in the 3D view by holding down the left mouse button and scrolling up. And we can see that we've pocketed out between these 2 vectors, creating this recessed area which we can add further detail to with additional toolpaths further on in the tutorial. Okay, so we're going to look at moving on to the next toolpath now. But before we do that, so that we can better understand the relationship between the 2D and 3D views, we're just going to switch over to a horizontally tiled view. So here we can see the 2D view at the top and the 3D view at the bottom. And now we're going to move on to profiling the inside of these outer vectors. So to do that, we're just going to need to select them first by holding down Shift and using the left mouse button. And we're going to close out of the preview toolpaths and open up the profile toolpath this time. And this time we're going to actually have to think about our start depth. So this is used when the area that you're looking to toolpath has already been cleared by a previous toolpath. And in this case, we've already pocketed out the material inside this outer vector down to a depth of 1/8 of an inch. So we can set that as our start depth, so we can do 1/8 equals. And this will ensure that the cutting doesn't start until the tool has reached 1/8 of an inch down from the material surface. And once the tool has reached the bottom of that existing pocket, we want it to cut down a further 1/8 of an inch, meaning that the total depth of the profiles that we're going to be placing on the inside of these outer vectors will be in total 1/4 of an inch from the material surface. The tool that we're going to be using this time, instead of the 1/8 inch, is the 1/4 inch end mill. And we need to decide whether we're going to be machining inside, outside or on. In this case, we're going to machine inside the vectors. And we can come down and just name this Profile Outer Circles. And we can calculate that. And now that's done, we can see the toolpath represented in both the 2D and the 3D view. But a good way of double checking these toolpaths is by switching on the solid view. So if we do that, we can then see in this blue area here the exact placement of the toolpath on the inside of the vector. And now I know that I'm happy with the placement of that, we can go ahead and preview. And we can see then that it's been cut away to leave this groove on the inside of the outer vector of the quatrefoils. Okay, so the next toolpath that we're going to look at is using the 1/2 inch ball nose to create a scalloped area around the inside of the 4 trifoils and also the 3 quatrefoils. But before we do this, we just need to use our 3D view to consider how these new toolpaths are going to interact with the existing toolpaths. So for the 4 trifoils, these are going to be okay because they're going to start from the material surface in this area. But with the 3 quatrefoils, these will be in an area that's already been pocketed away between this vector and this vector here. So that means we're going to need a different cut depth in this area to take account for this material that's already been machined away. But it might also mean that we need to change the start depth. So to check that, we'll just zoom in on the area a bit more, just to take a closer look, and we'll see that because we're using quite a large tool here that will be coming on the inside of this vector, it will mean that part of the tool will be cut in this central area that was left behind when we did the first pocket that we will be machining away later. So the cut depth needs to be set lower to account for the pocket, but the start depth needs to remain from the material surface, just to make sure that the tool gradually cuts through this area of material here, instead of plunging straight through it to complete its pass. Okay, so just by taking a bit of time to review the 3D view, that's told me that we can't complete this in one single toolpath for the trifoils and quatrefoils together, because our cut depths are going to be different. Okay, so we're going to start with the trifoils first. So we're going to come in and select the vectors that we need. And actually the internal vectors here are going to be used for the last profile pass on these trifoils later. So it's actually the outside vectors that we need. So we're going to select them, holding shift and using the left mouse button, close out of the preview and come back up to the profile toolpath. And in this case, the start depth again will be 0. Cut depth is going to be 1/4 of an inch. Instead of 1/4 inch end mill, in this case, we're going to be using the 1/2 inch ball nose. So we'll check that and check over the cutting parameters and feeds and speeds. We're going to want to be machining inside these closed vectors, and then we can just come down and we can call this Profile Trifoils, and we can go ahead and calculate that. And you can see that now in both the 2D and the 3D view, and you can see on the 2D view that we are inside the selected vectors by the diameter of the tool. So you can see that we're actually cutting across this internal vector that we're going to use for the profile pass later. And if we go ahead and simulate that now, we'll see that we've got a scalloped effect that it's creating, from which we're going to further sculpt with a profile pass at a later stage. Okay, so the next thing that we're going to want to do is consider doing the same as we've just done for the 3 quatrefoils. So to do that, we're going to make sure that we've got the outer vectors of these 3 selected. So again, holding down shift with the left mouse button. And we're going to close out the preview again and re-enter the 2D profile toolpath. Now, we've already established that even though the vectors that we're going to be applying this to are actually within the area of a pocket, we're still going to want to leave the start depth from the material surface because of this island of material that the tool's going to be cutting into. So that will be left at 0. Our cut depth again will differ from the trifoils because we'll need to take that pocket into account. So we cut down 1/8 of an inch in that pocket, so we need to add that onto the total cut depth. So instead we're going to have 0.375. We're going to be using the same tool, the ball nose 1/2 inch. We'll be machining inside the vectors again, and again we can just come down, and this one will be called Profile Quatrefoils this time. And we can calculate. And you can see now in the solid view why we had to still start that cut from the material surface, because it's still cutting away the area of material in the centre by the radius of the tool. So we can go ahead and preview that one now. And now you'll see that we've got a matching scallop border around both the trifoils and the quatrefoils. So that's great. And we now have one remaining profile toolpath before we begin to look at some V-carving. That would be using the same tool again, the 1/2 inch ball nose, to create a nice scallop line across the bottom and top of the quatrefoil to match these that we've already created. So with that, I'm just going to maximise the 2D view, and we're just going to centre that by zoom active view to selected limits. And we're going to want to access the top and bottom groove vectors that we switched off earlier. So we'll come back into the layers menu, and we want to switch off the foils now, and we want to switch on the top and bottom grooves. So the visibility is on. We then need to click that layer again to make sure that it's the active layer. So now that we can see our top and bottom grooves, the first thing that I'm going to want to do is run a centerline vector down the center of both of these rectangles. So to do that, we're just going to go back over to the drawing panel, and under create vectors, we're going to use the polyline tool. And with the geometry snapping switched on, we want to find the center of this end line by just moving the cursor in, and as soon as it changes to this symbol, we'll left mouse click, touch there, and then we'll move across to the right hand side, and just picking up that center line again, we can left mouse click again. And then I'm just going to hit the space bar, and that's going to temporarily take me out of the command but stay in the form, so that I can come back down and do the same for the bottom. So finding that center point, left mouse click, move across, and left mouse click to place that. And instead of using the space bar to come out of it this time and remain in the form, we're actually done with the polyline tool now. So instead we can click the right mouse button, and that will exit out of the form completely. Now we need to just take a second to think about how we're actually going to machine these top and bottom grooves. So because we're using a 1/2 inch ball nose to machine this, it's actually not going to machine right up to the corners at the end of our vector, and it's going to leave a radiused end. So what I want to do to counter this is actually extend these vectors up to the edge of the workspace, so that when we profile around this later to get our required dimensions, we'll get a nice clean edge. So there are a few ways you could go about doing that, but I think the most straightforward here is if we shift and select both of the lines, and then click again to put that into transform mode. And you'll see now to the right and to the left these kind of sizing points or handles. So if we hover our mouse over this and left click and holding that down, we can just stretch this end out and just come over and do the same to the other side, just extend it past there. And now we can see that we've extended these lines past these vectors, just so that when we run our 1/2 inch ball nose, it will extend past the end, and then we can trim this area away with a profile pass to give us a nice sharp clean edge, as opposed to a radius end. Just clicked off, so we just need to select those again. And then we can come back over to our Toolpaths tab, close out of the preview, and we can think about applying the toolpaths to these. So I'm going to need the profile toolpath, and in this case, I'm going to use the start depth of 0 because we'll be cutting fresh material. Our cut depth will be 1/4 inch. Our 1/2 inch ball nose is already selected. We'll be machining the vectors. We're not going to machine inside or outside, but this time actually on the vectors. And then we can come down and we'll just call this profile top and bottom grooves. And we can click calculate. And you'll see that toolpath shown there in the 3D view. We'll just horizontally tile that. And we can see up here in the solid view that the toolpath is extending past the ends of these vectors here. And then we can just play this. And now we can see these scallop lines on the top and bottom, which are now long enough for us to trim off to create that sharp edge. So that looks perfect, and now we can move on to adding some V-carving to our quatrefoil. So the first thing that we need to do to add our V-carving is to come up to the layers menu, and we're now going to switch off the visibility of the top and bottom grooves and switch on the visibility of our V-carve shapes, and then we're going to select that again to make sure it's our active layer. And you'll see on this layer a number of shapes, some of which fall within the quatrefoil region and some which are outside on the flat areas. And as a consequence, even though these are going to be machined with the same tool and the same toolpath, we'll actually need to create them as two different toolpaths, bearing in mind that the start depth of these inner VCarve shapes will actually be lower than the start depth of these outer shapes because they'll be machined into fresh material. So first of all, if we look at machining the outer VCarve shapes first, so if we box pick these from right to left and holding down shift, we'll select the bottom ones and these two central ones. And with those selected, we're going to come across and close out the preview. And this time under toolpath operations, we're going to need the VCarve Toolpath. And the first thing that we need to do in the form is select which tool we're going to be using. So we'll come into the tool database. And in this case, I'm going to be using the 90° 1 1/4 inch V bit. So we'll select that. We can check over the settings. Okay. The start depth is going to be 0 because it's from the material surface. And in this case, we're not going to need to specify a flat depth. So we're going to allow the geometry of the tool to find its natural flat depth. And we don't need to worry about anything else in the form for now. So we can just come down and we'll call this VCarve Outer. And we can click calculate. And then you'll see the toolpath presented in the 3D view and also in the 2D view. So I'm going to come across and preview that. And you'll see that that's created these really detailed shapes in between our trifoils and around the outside of our quatrefoils. And now with that done, we need to consider these internal shapes which are going to sit on top of the original pocket that we created with the first toolpath. So we'll just go through and select these. So holding down shift again, can box pick these, make sure I've got all three selected. And with that, I can move back over, close out of the preview and go back into the VCarve toolpath. And in this case, the start depth isn't going to be 0 because we've already machined away some material in this area. And the depth of those pockets, if you remember, was 1/8 of an inch. So we can enter that as our start depth, so 0.125. We don't need to specify a flat depth again, and we're going to be using the same tool, the V-bit 90° 1 1/4 inch. So we can come down and we'll call this one VCarve Inner and click calculate. And again, you'll see that displayed in the 3D and the 2D view. So I'll just come across and I'll play that one on its own. And you'll see now that we're left with this VCarve detailing around the outside of the quatrefoils in the pocketed region. And now I'm happy with our VCarve shapes now, so we can move on to the last part of this, which is going to be the profile pass around the outside to trim away our part from the material, but also to cut away the internal pieces of these 3 quatrefoils and 4 trifoils. So again, we're done with this layer now, so we can come back up to the layers menu and switch off the VCarve shapes, and we're going to need to switch on the foils and also the outline layers. And we'll just click to make the outline layer the active layer. And now we'll just need to decide which vectors I'm going to be using for the profile pass. So I need to select the outer rectangle for the profile and also the insides of the 3 quatrefoils and also the 4 trifoils. And now we need to just consider on which side of these closed vectors we're going to be machining. So obviously for the perimeter vector, we're going to want to machine outside. But for the 3 trifoils and 4 quatrefoils, we're actually going to want to machine inside the closed vectors. Now, because of the nature of the profile toolpath, it actually knows that if we've got a nested routine like this, to machine outside the external vector and inside the nested vectors which are within the external vector. So with our vector selected now, we can come across and close out of the preview again. And this time we're going to want a profile toolpath. And our start depth is going to be from the material surface again. Our cut depth will be the full thickness of the material. And again, if I don't know that, I can hit Z equals, and that will give us the cut depth of 1 inch. The tool that we're going to be using in this case will be the 1/4 inch end mill. And again, we just need to consider where we're going to be machining these. So we'll do this in relation to the external vector, which will be outside. And then, as I said earlier, due to the nature of the profile toolpath, because of this nested routine, it will know to machine internally these inside vectors. So the software just takes care of that automatically so that you don't have to create two separate toolpaths, one for the profile and one for the quatrefoils and trifoils. So now we can move down, and we're not going to add tabs in this case. We'll assume that it's either going to be stuck down or that it'll be held down using a vacuum table. But what I do need to do in this case is add some leads. So first of all, you're going to want to make sure that Show Advanced Toolpath Options is checked. And then we can click on the Leads tab and check this checkbox to add the leads. Okay, so the radius is going to be 1 inch, and the lead length, the amount that it arcs out, is going to be 1/2 inch. And I'm going to choose yes, do lead out, and the overcut distance is going to be 1/4 inch in this case. So we can see from the diagram here that we'll be arcing in, and then we'll do a full pass, and then we'll come back and we'll overcut by 1/4 inch before doing the lead out. So we'll see that in just a second, but I'm just going to come down and we'll call this profile cutout, and we'll click calculate. And you'll see that it's actually thrown up a warning message. So it says, to avoid gouging, one or more leads had to be reduced in length or removed completely. Check the toolpath is still suitable for your requirements. What this is telling you is that in some of these areas where we've got less space between the toolpath and the material that's already been machined away, because of the large lead length and diameter of the leads, in some cases it's had to be shortened or otherwise removed completely where it's going to interfere with the rest of the part. So if we just OK out of this now, and we'll just zoom into the part just to have a look at these areas. So in some areas you'll see down here at the bottom left hand corner, you'll see this lead in and lead out. But in this case, it's actually right on the edge of the external profile, so you may want to reposition that. And there are a number of ways to do this, one of which is you can do this manually by coming into the profile and changing the start and end point. Or alternatively, I can actually use the toolpath menu and change the start position. So I'll go back into the 2D profile toolpath. And if we come down to the same section that we found our leads tab, there's another one called start at. So if we click on that, and you'll see that at the moment we've got optimized start point selected. So at the moment the software's automatically selecting where it thinks the start and end points would be most logically placed itself. But there's another option called move start points to be closest to selected point on vector bounding box. So if we click this option, and once you do that, you'll see a number of different points displayed around a bounding box. So essentially, if you imagine all the vectors that you're looking to machine having a bounding box enclosing them together, and you're essentially selecting a point on this bounding box from which you'd like the tool to approach from. So in this case, I'm actually going to choose the top center, and we'll click calculate again. And the error message will come up again, so that's still telling us that in certain areas, we'll still be violating the material if we don't change the lead. So we can click OK. And if we zoom out now, we'll see that that's now been placed or repositioned at the top center edge rather than down at the bottom left. And if we come up and just switch on the solid view, we can see that in the 2D view as well. And that's just to show you that by using the start at section in the profile menu, if you've got a number of different shapes selected that you're looking to profile together, instead of changing the start points individually, you can just enter into that form and manually select a position from which you'd like the tool to come in from. But I'm happy with the placement of that now, so I'm just going to click to play that out. And you'll see now that in the 3D view, that's displaying the profile cutout and also the internal parts of the quatrefoils and trifoils. And you can see now that there's some waste material left in this area. So in the 3D view, we can double click on these to remove them. So I'll just go around and remove all of these, and we can have a look at the final shape that we're presented with and also the profile. And now you can see the fantastic quatrefoil shape that we were going for. So I'll just maximize that. And that's the finished part you can see on the screen. So at this point, you can now go ahead and save your toolpaths to output to your CNC machine. But to learn how to do this, please refer to the dedicated toolpath saving guide tutorial that you can find in the related video section for this tutorial.